Can you send the link as well?
Yeah, of course. Question 1. A block of mass 2.5 kg is placed on a plane inclined at 30 degree. This is the plane inclined at 30 degree. There is our block and its mass is 2.5 kg. The coefficient of kinetic friction between the block and plane is 0.12. Okay, if the block starts from rest, so this block starts from rest, that means its initial velocity was 0, right?
Yeah.
Rest at the top of 4-meter long incline, that means this distance is 4 meter. Okay, yes or no?
Yes.
We need to find its speed at the bottom. So let's say here the final speed is v. So we don't need these data. Okay,
Okay.
we can actually use energy conservation, right?
Yeah.
Or what we could do here, yeah, no, we can't use we cannot use energy conservation here. Why? We can actually use it. Okay, let's call this distance h. Okay,
Okay.
so here sine theta is how much? Sine theta is what? Perpendicular upon hypotenuse, right? This is perpendicular.
Yeah.
This is hypotenuse. So
Yes.
from here h is how much? D sine 30 degree, right?
Yeah.
And what's the d here? D is 4 meter and sine 30 degree is 1/2, right? So the height is 2 meters, yes or no?
Yes.
So we got the height, that is 2 meters, right? So we can use energy conservation. Initially it had only potential energy, that was mgh, right? And at the bottom its energy is totally kinetic, right? That means it is half mv square, yes or no?
Yeah. That's
So
right.
we can cancel out these masses. So v comes out to be under root 2gh, right?
Yeah.
Okay.
Okay.
That would be 2 times 10 times height is 2 meters, right?
Yeah.
That is how much?
Yes.
Under root 40. Okay.
Okay.
But here we do need to consider the work due to friction. Okay. That we must subtract from this, right? This is our, that is our mistake here. Okay. We do need to subtract the work done, right, due to the friction.
Yeah.
That would be F times T. Now friction is how much? This is normal. This is mg cos theta, right? Cos 30
Yeah.
degree.
Yes.
So
Correct.
this would be mu mg cos 30 degree, yes or no?
Yeah.
So just plug it here. Mu mg cos 30 degree. This is mgh. We can cancel out this masses. So gh is equal to half mv square minus mu g cos 30 degree. Okay.
Okay.
Now plug the values, you will end up with the answer. Okay, this is 10, this is, height was 2 meters, right? We just found it out. Yes.
Yeah.
Half, we cancelled out this. We need to find v square. Value of mu is 0.12, g is 10, and cos 30 degree is root 3 by 2. So if you solve this, you'll end up with the answer. Okay, that will be your speed. Okay,
Okay.
good. I'm not solving it. This is just a calculation. Okay, all
Yeah,
right.
okay. I, yeah.
Now let's move on to next question.
Number of 4.
Number 4. Question number 4. A flywheel of moment of inertia, here it is 0.8 kilogram meter square, rotates with an angular speed 120 radian per second. Okay. A brake applies a constant torque is how much? 12 Newton meter. Okay. Bringing it to rest in 50 seconds. Compute the angular acceleration. We need to find the angular acceleration. Angular acceleration is alpha. Okay. And work done by the brake will be what? This is our question. So torque is equal to I alpha. Okay. This is the formula. Alright.
Yeah. Okay.
Here torque is given, that is 12. Moment of inertia is 0.8. So you can easily find this alpha, right? You
Yeah.
can easily find it. That is 120 by 8. That is how much?
120 by 8, that's like 15.
Radian per second square. Okay. Now work done. We need to find the work done. So work done due to torque is tau d theta. Okay. Or tau theta. Tau is torque. Okay. We need to
Okay.
find angular displacement, right?
Yeah.
Okay. Omega is given. That is 120. Final angular velocity is 0, right?
Yeah.
Time is given, so we can find out the, yeah, and alpha is also given, that is 15, right?
Yeah.
Okay, so we can use this formula. Theta is equal to omega 0 t plus half alpha t square. Okay,
Okay.
here we need to find the theta. Omega 0 is 120, time is given, that is 50, minus alpha. Alpha, what's the value of alpha? That is 15, and this is 50 square. Okay,
Okay.
so if you plug this value of theta here, you will end up with your answer. Okay, that would be the work done in this case. Okay, understood?
Yeah.
I'm not solving the calculation. Okay, it's up to you. The concept is this. Okay, this was a pretty advanced question, I think. All right, and very good question. Now tell me next
Okay.
question. Are you familiar with this formula? Remember we had this formula in translation motion, that d is equal
Yeah.
to ut plus half at square. Remember?
Yeah.
So same way this is the formula in rotation. Okay.
Yeah.
Here you just need to replace this initial velocity, linear velocity with angular velocity, and linear acceleration with angular acceleration. Understood?
Yeah.
Good. Tell me the next question.
Yeah. Next question. Can you scroll? Yeah. Can you scroll down?
Yeah.
Uh, I want two. I want to double check two.
Which one? Okay, so let's do question number 9. A 0.2 kg ball is moving with a speed 5 meter per second. Collides elastically with a stationary ball. So this is our ball moving with velocity u. It collides with a stationary ball. That means u2 is 0. This is u1. Okay. Find the velocities of both balls after the collision. So after the collision, they stick to each other, right? And let's say they move with the velocity v. So we need to find this velocity, okay? So this is pretty easy. You just need to apply momentum conservation, okay? It says that initial momentum is equal to final momentum. Here initial momentum is mu1. Since its velocity is 0, so we don't need to count it. And the final momentum would be, here its mass is 0.6, this m2.
That's K.
So this, here the mass would be 0.8, right? So 0.8, first write this down this way, that it is m3. Let's say this is m3 multiplied by v, okay? m3 multiplied by v. So we need to find this v. It would be mu1 divided by m3, right? M was what? 0.2. u1 was what? 5. And m3 is 0.8. So this is 5 by 4 meter per second. That is your answer. Understood?
Yeah.
Easy?
Yeah.
Tell me the next question. So in question number 11, we need to find the angular speed of C, right? So first step should be determine the relationship between gear A and gear B, right? Relation between A and B. So gear A and B mesh, right? Meaning their linear speed at the point of contact are equal. Yes or no?
Yeah.
So the relationship between the angular speed and radius of meshing gears is given by omega 1 r1 is equal to omega 2 r2. Yes or no?
Yeah.
Also, you need to remember that meshing external gears rotate in opposite direction, okay?
Okay.
So omega A RA is equal to omega B RB, okay? So from here omega B is equal to omega A multiplied by RA by RB, right?
Yeah.
Now omega A is given, that is 400 RPM, as you can see, right? So 400 RPM multiplied by the radiuses are given 2 centimeter upon 6 centimeter. So it would be how much? 400 divided by 3 RPM. This is the angular velocity of gear B, right?
Yeah.
So since gear A rotates clockwise, gear B rotates counterclockwise, okay?
Okay.
Yes. Now the relationship between B and C, okay?
Yeah.
So gear B and C are on the same axle, as you can see, right?
Yes.
In question it is given that gear B, which is on the same axle as gear C. So that means same angular speed, right? In same direction, yes or no?
Yes. Correct.
So omega C would be 400 divided by 3 RPM. So these two will rotate counterclockwise, right? Same as that of the B. So answer should be 400 divided by 3 RPM counterclockwise. Understood? Which is roughly 133.33 RPM. Understood?
Okay.
Yeah, let's do question number 14. A wedge of mass m has a small block of mass m sliding down its frictionless incline of angle 35 degree. So for our convenience, we'll take this angle to be 30 degree, okay? Since there are no MCQs, okay? Just for understanding and to make the easier calculation, okay? But don't do this in exam, okay?
Okay.
So wedge of mass m. So the mass of this wedge is m. Has a small block of mass 2 kg. So this is our block of mass 2 kg. Wedge's mass is 10 kg. Sliding down its frictionless incline of angle 30 degree. Here it is 35 degree. Causing the wedge to move on a frictionless horizontal surface. So since this is sliding down, this wedge is also sliding in this direction, right? Here the surface is smooth, okay? Find the acceleration of the wedge and the block relative to ground, okay?
Yeah.
No other data is given, right? So here
Yeah.
this is mg
Why are we
cos 30
assuming that
degree
it's 30 degrees?
and this is mg sin 30 degree, right?
Yeah.
So basically this smaller mass moves with the acceleration g sin 30 degree, yes or no? Let's
Yeah,
call it
correct.
a1, okay? And let's call this the acceleration of this bigger wedge or wedge is to be a2, okay? So if you make the
Okay.
free body diagram or vector diagram, it looks like this way, yes or no?
Yeah.
This is a1, this is a2, right?
Okay.
Which is making an angle 30 degree, yes or no?
Yeah.
So you can take the components, right? This a1, the component of a1 in horizontal direction would be a1 cos 30 degree, yes or no? That is our a2,
Correct.
correct?
Correct.
So a2 is, what was the value of a1? It was g sin 30 degree. So g sin 30 degree multiplied by cos 30 degree, right?
Yeah.
So the value of g is 10, sin 30 degree is 1 half, and cos 30 degree is root 3 by 2. Yes or no?
Yeah. Right.
So this would be how much? This is 10 by 4, that means 5 by 2 root 3 meter per second square. This would be the acceleration of the wedge. Are you getting my point?
Okay.
Okay, this was a bit harder question. Okay,
Okay.
good, happy.
Yeah. Okay.
Next question.
Um, engine force. Kepler law is not another thing.
Let's do question number 20. A block of mass 4 kg is attached to a rope wrapped around a drum. This is our drum. Drum means a cylinder, okay? And this is the rope.
Yeah. Okay.
So the radius of this drum or cylinder is 0.15 meter. The rope is pulled with a constant force 30 Newton. So this is rope and we are pulling this rope, okay? With the force
Yeah.
30 Newton, causing the drum. So the mass of the drum is given, or basically mass of this cylinder is given, that is 1.2 kg. And it's a solid cylinder. It is also given. Okay? It
Okay.
rolls without slipping. Find the linear acceleration of the block and angular acceleration of the drum. Okay?
Okay.
So first of all, the weight of this block is 40 Newton, right?
Yeah.
Okay, and the rope wrapped around a drum. The rope is pulled with constant force 30 Newton, causing the drum to roll without slipping. Find the linear acceleration of the block and angular acceleration of the drum. Okay. So if we
Yes.
are, let's say, pulling this rope in upward direction with the force 30 Newton. So now you must be familiar with the moment of inertia of the cylinder, solid cylinder. Okay, that is mr square by 2. Are you getting my point?
Y by 2.
Yeah, that's the formula I told you. Remember in the previous session that the moment of inertia of a solid cylinder is mr square by 2. Okay, so here, but they didn't told us where the, yeah, so here we can use torque equation. Torque is equal to I alpha, right? Here torque is
Yeah.
force multiplied by radius, right? Yes or no?
Yeah. Yeah.
Is equal to mr square by 2, and we can write this alpha as a by r, right? Yes or no?
Yeah. Okay. Yeah.
Sorry, Aman.
Hello.
Sorry. So we can cancel out this radiuses, right?
Yeah.
Force is given, that is 30 Newton. Here mass of the cylinder is how much? 1.2 kg multiplied by the acceleration. So which is how much? This is 0.6. So acceleration is 30 divided by 0.6. That gives us 6, 5, 30. So this is 50 meter per second square. Okay.
Yeah.
So linear acceleration is 50 meter per second square. So this block will also move with a linear acceleration of 50 meter per second square. Okay, this is the answer. Are you getting my point? This question was a bit difficult. I know. Good. And you can expect this question in your exam. Okay, question number 29. A block slides down an incline of height 2 meter. So here height is 2 meter, right? Initial speed is 0. If 15% of mechanical energy is dissipated by friction, so by friction, how much energy is dissipated? 15% of energy. Okay.
Yeah.
Find the speed at the bottom. This is the same question as we did before. Okay.
Yeah.
So let's first find out the total mechanical energy at the top. Okay. So at the top, total mechanical energy is nothing but potential energy plus kinetic energy, right?
Yeah.
Here kinetic energy is 0 as its speed is 0 at the top. So it has only potential energy, that is mgh, and its value would be, here the mass of the block is not given. Okay. So we will
Yeah.
assume that the mass is 1 kg. Okay. 1 into 10 into height is 2. So it is 20 joules, right?
Yeah.
So 15% of this energy is dissipated. Okay.
Okay.
So what's the 15% of this energy?
15% of what? Why does P plus K equals mgh?
No. Kinetic
Isn't
energy
that
is 0. Kinetic energy is 0.
okay?
Okay. So 25 5 multiplied by 3 is 15. So this is 3 joules. Okay.
Okay.
So the kinetic energy at the bottom would be what? Total energy, that was E, minus
Yeah.
energy dissipated by friction, right? Total energy
Yeah.
is E, that is 20 joules, yes or no?
Yeah.
Minus energy dissipated by friction, that is 3 joule. So it would be 18 joule. Okay, this would be the answer. Understood?
Okay.
Any question from the fill in the blanks?
No.
Good. So we discussed all the doubts, right?
Yeah.